what I planned on doing originally was after the first and the second task, you know, we have the group or groups that got the correct answer in whatever amount of time that they did, and then we would go over task 1 and what would the correct combination of zeros and ones be to represent those numbers in task 1. And then task 2 is where I would have the students introduce to themselves this notion of algorithms, right? So the steps that the students would write down on the task 2 paper would basically be their algorithm for solving this particular problem. Okay? I expect for the younger students, let's say middle school, them have to like sit there and actually write out all the different combinations. And that's doable. You know, it's not, I did it myself, and it's doable. I did it in like 10 minutes, so I'm thinking they can do it in about 20 minutes, let's say, right? So, and then we will talk about it. So let's just talk about it first really quickly, like a 2-second discussion about, what steps did people take to find how many numbers can be represented with a 5-string binary. Okay.
We just try to find the highest number and then like work from there, because if each group of 5 is like representing a number, then you can only go from the highest to the lowest, so we just went for the highest and then
went down. That's a great strategy.
Yeah, and then we came up with 0.
So that's like algorithm 1, right? You would start from the greatest number possible by putting ones in every space, and then work down, right? Because you can't have anything greater than that number, right? Okay.
I don't know if I did this necessarily in terms of an algorithm, but I just like wrote out like a blank spot for 5 spaces and was like, okay, well, only 2 options can go into either space, so you would just do 2 times 2 times 2 times, like to get the total number.
Right. Well, that is an algorithm. Yes. And that's actually the most effective algorithm you can use, 2 to the 5th. So anytime, just combinatorics, it's like a higher level thinking. I won't say this to my students, but anytime you have two possibilities with n sort of spaces for those possibilities to be, it'll be 2 to the n. Okay. Anybody else? Algorithms. You guys said 5 factorial, right?
I know I'm wrong.
But that's okay. That's okay. But why did you think that? What steps did you take to come up with 5 factorial? Because that's equally as important.
Well, they started writing it down. I was just like, that is way too long. I was like, and I know that there's an easier way to do this, and factorial is popped in my head because that's what I remember. But it's multiples instead of like the addition. This is like addition or 2 times n versus all the multiples of the number. Okay. Anybody else? So even though they did not get the correct answer, the process in which they were going through, right? They started out with one kind of method. Then they started to refine that method. And they say, no, there has to be an easier way. There has to be a more effective way. This is exactly what computer scientists do when they're writing programs and they're writing algorithms. And then we'll sort of end off with that note, what an algorithm is. And then the next sort of lesson will be on algorithms